Okay, a bag contains X counters. There are only red counters and blue counters in the bag. There are 4 more blue counters than red counters in the bag. Finty takes at random 2 counters from the bag. The probability that he takes 2 blue counters from the bag is 3/8. Work out the value of X, where X is the total number of counters. So it seems to me that we're going to set up an equation that equals 3/8 and solve it in some way. This is a really important piece of information here because it allows us to relate B and R, right? Let's call the number of blue counters B and the number of red counters R. Once we can relate them, we can get B equals some expression to do with R, or R equals some expression to do with B. And we can use that knowledge to eliminate one of R or B from our calculations. And that will give us an equation in one unknown, either B or R. And in fact, you can do it in X straight away, but I think it is a bit more fiddly, such that it equals 3/8. And then you can solve it because there's only one unknown. So we'll go ahead and do that. The first thing to do, I think, is to write down an equation that relates B and R. So I'm going to ask you to pause the video and see if you can do that. Right, so there are 4 more blue counters than red counters in the bag. That means there are more blue than red. I've decided I'm going to eliminate R. So I want an expression that begins with R equals. But you can do it either way. And I can see that R equals B minus 4. You've got to be careful getting this right. Sometimes it's difficult to get your head around these things. But B is definitely bigger, isn't it? So if you take 4 off B, you get R, right? Okay. What we can now do is think about these probabilities. We know, for instance, that the probability of him taking out a blue counter first is just the number of blue counters divided by the number of counters. And you can write that like this, B over X. But what would be useful is if we could write X purely in terms of B, because in the end, we want some expression here equals 3/8. And we only want this expression to be an expression in B. We don't want any X's in there. So I'm going to ask you again to pause the video. And this time, you're going to write an expression for X. So you're going to have X equals, and you're going to have an expression only in B here, okay? So have a little think about that, pause the video, and then come back when you're done. Right, well, we know that X is B plus R, the number of blue counters and the number of red counters, because there are only blue and red in there. And we know that R is equal to B minus 4. So this is B plus B minus 4. And that's equal to 2B minus 4. So that's the total number of counters in terms of B. And we can now write the probability that Finty takes out a blue counter first in terms purely of B. So pause the video and write down the probability in terms of B alone that Finty takes out a blue counter first. Right, so the probability that he takes, let's write it down, probability that first is blue equals, well, it's still the number of blue counters, and it's out of the total number of counters, but the total number of counters we've decided is 2B minus 4. So that is the probability in terms of B alone that he takes out a blue one first. Now then, this is a little bit harder. You need to think a bit more carefully. Probability that second is blue. And again, I want you to write it in terms of B alone, bearing in mind that a blue one has already been taken out. So pause the video and have a go at that. Right, well, there's not B blue counters anymore. There's B minus 1. And there's not also 2B minus 4 counters left in the bag. There's 2B minus 4 minus 1 because you've taken one out. So that's 2B minus 5. So you've got those two probabilities. The next thing we can do is set up this big equation that equals 3/8, because this is going to be the probability that both of them are blue. Just pause the video and write down an equation that results in 3/8 and is the probability that both of those two counters are blue. Okay, so if you want the first one to be blue and the second one to be blue, then it's going to be the product of those two. So it's B over 2B minus 4 times B minus 1 over 2B minus 5. And this whole first phase of solving this question is just setting up that equation. And you've got to go carefully and get it right, because if you get it wrong at this stage, then all of this working that you're going to do now is going to be worthless, and you're not going to get marks for it. So it's probably worth just having a quick check that we've done that right. I think we probably have. We're going to end up, we've only got one unknown here, so we can definitely solve it. And it's just going to be a question of algebraic manipulation to simplify this. So the next, I would say that the first thing to do is to get clear these fractions so that we've got all of our b's on one line. And you need to have a think about how you're going to do that. I think the first step is probably to write this thing here as just one big fraction. So pause the video and work through that, you can simplify it if you like, because I think it's going to involve some brackets, but it should just be one big fraction. So pause the video and do that. Okay, so we just need to multiply those two together and multiply those two together. So we're going to have B minus 1 on the top, and on the bottom we're going to have 2B minus 4 times 2B minus 5, and this whole thing here, let's delete a little bit of that because it's too long. That whole thing there equals 3/8 still. Let's go ahead and simplify the top and the bottom so that we've expanded out the brackets. In fact, maybe there's no need to do that at this stage. We can do that. We can do that now, or we can do it later. Let's say we do it later. What we now want is an equation where there are no fractions at all. And you need to think about how you're going to do that. Okay, so we want just an equation which is just one long line of stuff with no fractions at all. So pause the video and have a think about how you're going to do that. Okay, well, if I multiply both sides of this by 8, then I'm going to end up with an 8 up here, and this will disappear. And if I multiply the whole thing by this, then that will move up there. This is called cross multiplying. Okay, so that's what I'm going to do. Let's get rid of this just so you can see. I'll get rid of the 8 there. So I'm going to end up with 8b minus 1 on that side, and I'm going to end up with 3, because we normally put the numerals first, 2b minus 4, 2b, let's do that again, 2b minus 5 on that side. And I can multiply all of this out. I can see immediately that here I'm going to be multiplying b times b. So I'm going to end up with a b squared. And I think I'm going to end up with a quadratic. So let's just do that. If you pause the video and multiply out those brackets. Okay, so 8b times b is 8b squared. 8b times minus 1 is minus 8b. And then I can multiply all of this out. So I'll do the first bracket first. 3 times 2b is 6b. 3 times minus 4 is minus 12. And all of that now is going to be multiplying 2b minus 5. And I'll have one more line here just to make sure that I do it carefully. 8b squared minus 8b equals, now 6b times 2b is 12b squared. 6b times minus 5 is going to be minus 30b. Minus 12 times 2b is minus 24b. And then minus 12 times minus 5 is plus 60. And looking at this, it is a quadratic. These b squareds are not going to cancel because I haven't got the same amount on both sides. So I am going to end up in with a quadratic with some b squareds, some b's and some units. And I need to, in order to solve that, I need to set it all to 0. And there'll definitely be a mark in the mark scheme for doing that. So pause the video and rearrange this so that you've got everything on the left equals 0 on the right. Okay, now in order to get stuff on the left, I might want to subtract 12b squared from 8b squared, but I don't really want to be left with a minus 4b squared. So I'm in fact going to get the 0 on the left here. And then I'll just rewrite it. So 12b squared minus 8b squared is going to give me 4b squared. Here I've already got minus 54b squared. 54b there. And I want to add 8b to it. So minus 54 plus 8b is going to give me minus 46b. And then I've got my 60 there that I'm going to keep. So it was 4b squared. Then I decided it was minus 46b, still plus 60, and that equals 0. I'm going to have a quick scan to make sure I've done that right. Okay, so that looks right. I think it's probably easier for me to divide through. I can see all my coefficients here are even. So if I divide through by 2, I don't need to factor out the 2. I don't need to keep it, because if I do 0 divided by 2, I've still got 0 on that side. I'll just divide everything by 2. So 2b squared minus 23b plus 30 equals 0. And I can't factor anything else. I can't divide through by anything else. 23 is prime, so I certainly can't divide through by that. And I can go ahead and solve this. Now I could put it in the quadratic formula. I don't think it's a very sensible thing to do because it's a lot of faff with your calculator, and you've got to write the substitution down as well. So it takes quite a long time to do that. Much better, I think, is to get to a stage where you're reasonably confident about how to factor these kinds of things, and they're always going to give you something that's factorable. So I'm looking for, as usual, 2 numbers so that I can split this middle term. And those 2 numbers need to add to minus 23, but they need to multiply to the product of those 2. So they have to add to minus 23 and multiply to 60, and I can see those two numbers are going to be minus 3 and minus 20. And it doesn't matter how I split this middle term. I can do minus 20b minus 3b, or I can do minus 3b minus 20b, doesn't matter. So let's do the latter. So I end up with 2b squared. Let's do minus 3b, then minus 20b. So I've still got minus 23b in total, and then plus 30, and that's still equal to 0. And then I factor each half of this separately. So I'm going to look at this bit first and factor it, and I can certainly take a b out. So I'll do that, and in the brackets that will leave me 2b minus 3. And then I can look at this other side. Now I've got a minus sign there, so I want to factor a negative number out. Otherwise I'm going to be left with a funny little minus sign before the first term in the bracket. The highest common factor of 20b and 30 is going to be 10. So I'm going to factor out minus 10 and then think about what's left in the bracket. Now, if you do this correctly, and putting plus 0 is not correct, it's equal to 0. If you do this correctly, then this expression in here will be the same as this. In fact, if it isn't, it's a sign that you've done something wrong and you need to go back. So I should be able to put 2b minus 3 here, and I'll just check by mentally multiplying this out that I do in fact get this. So minus 10 times 2b certainly gives me minus 20b, and minus 10 times minus 3 certainly does give me plus 30. So I've done that factoring correctly. And then given that I've got b amount of 2b minus 3 and I've got minus 10 amount of 2b minus 3, I must have b minus 10 amount of 2b minus 3, and that is equal to 0. Now the reason that we do all this equaling 0 thing is that when we end up in the factored form like this, if you've got two things multiplied together and the answer is 0, either one or the other of them has to be 0. There's no other way of doing it. And I can see here that b could be 10, because that would make this first one 0. Or I can say that b equals, and then just doing this in my head, I would subtract 3 and then divide by 2. I'd end up with 3 over 2. So I've got two possibilities for the number of blue counters here. It's either 10 or it's 1.5. Now, it makes no sense for there to be 1.5 blue counters in, so I just reject this. Okay, and sometimes this does happen if you've got sort of physical constraints, like you can't have 1.5 blue counters, or the length of a fence can't be negative. Then you just ignore one of your quadratic solutions. So I now know that the number of blue counters is 10, and I know going right the way back to here that the total number of counters, x, which is what I'm looking for, is 2b minus 4. So I now just go ahead and do that. So x equals, and I can say 2b minus 4 equals 2 times 10 minus 4, and that's equal to 16.